All right. So hopefully someone's going to show up. Just wanted to point out that I'm having another scheduling issue and that Wednesday, April 6th, there's going to be no MDE 54. Same as last time, we'll still have Math 154. It's just going to be no MDE 54. I just have these scheduling issues and I just can't work them out, but this should be the last time that happens. I don't anticipate this happening again for the rest of the semester, but it's just one of those things. Thankfully, as long as we have the Math 154 course, it's not too bad. But yeah, so what we're going to do today is we're going to talk about exponential functions. We got into that in Math 154 for most of the day. So we're going to show you those formulas again. We're going to show you how to use them. We're going to do some practice problems. We're going to do some stuff with Excel involving them, not necessarily using the formula, but how you can do it in Excel as an iterative process, and show you some comparison and contrast examples. So let's go ahead and get into that.
Today is I want to spend our time kind of doing more of this exponential growth, this constant percent change growth. I want to do it in all the manners you've seen me in my regular class if you're my regular student. So I want to do one or two more with Excel. I want to do several by hand. I want to use the formula to get to, say, the 50th year automatically. I want to do it iteratively, which means year by year to get to the 50th year, not necessarily year 50, but just a certain point. You get the idea. So, as a reminder, with constant percent change, aka exponential growth, there are two different things we can say. We can say that the new amount is equal to the previous amount, or the old amount, times a growth factor or decay factor I'm not saying times and divided by, I'm just saying one of these. You either grow or you decay, it's one or the other. And you say that the growth decay factor is 1 plus or minus r. So it's new equals the old times 1, and then plus or minus r, depending on growth is a plus, minus is a decay. Now this is how we go from year 5 to year 6, or to go from year 2 to year 3, or to go from year 0 to year 1, or from year 1 to 2, or from 50 to 51. So this is to go between 1, I'm putting year in parentheses for a reason, I'll explain in a second, between 1 year and the next year. Again, year in parentheses because it doesn't have to be year. If we say that our interest accrues monthly, then it could be months, or it could be days, or it could be weeks in some weird world, or quarters, or semi-annually, which would be twice per year. So the year here can be months, days, quarters, etc. Just depends on the problem. Just depends on how frequently the compounding occurs. And remember, compounding means that that's when we're gaining or losing. It's not traditionally called compounding in the same way when it's a decay, but it still works. We're still going to call it that. So when I say we gain interest every year, then we're compounding annually. If I say we're gaining interest every month, which I haven't done in regular class yet, and I'm not going to do today because of that, then we would be gaining interest every month. January, gain money. February, gain money. March, gain money. April, gain money. All we're considering for now is just gaining money every year. But again, any timestamp is a possible scenario. It just depends on the context. When you're in the real world, Anything having to do with mutual funds, stocks, bonds, they're daily. Anything having to do with savings accounts, there's kind of a weird amalgamation of things involved with that. They do it as a daily rate generally now, but they only give you the interest quarterly. And that's actually, that little catch-22 is to avoid giving some people money, because let's say you're going to gain money in January and then April. If you close your account in February, you won't gain the 1 month of interest you earned, because the interest doesn't actually go into your account until, what did I say, April? Yeah, April. Even though the interest was probably accruing daily. Again, that's just how banks, these brick and mortar banks, tend to do their savings accounts. Now, I can't say every bank does that. I can't even say most. I'm just going to say I feel like it's most. I would say more than half. But I cannot say that I have looked at every single bank's 300-page long inner workings and all that stuff. All right, so new equals old times 1 plus or minus r. And we showed in my regular class how if you wanted to do this over multiple years, this 1 plus r, every year you just get another one, and then another one, and then another one, and then another one, and then another one. And you'll have as many of those as the years or months, as we'll do later, or days, as we'll do later, go by. So that's how that exponent got involved. So we said, or to get to any year, and I'm saying any year, I'm not putting the year in parentheses this time because this formula only works for years. A equals P parentheses 1 plus R raised to the T, where we said previously, A we call the future value, the ending value. P is the starting value, also known as the principal. R, of course, is your annual rate, and T is your time, years. So please understand this is years only when we're compounding annually. If you see a problem that says we're compounding monthly, this formula's out. If you see a problem that says we're compounding daily, this formula's out. If you see a problem that says we're compounding twice a year, twice isn't once, that formula would be out. We'll see that next class. So again, we have this to go from year to year to year to year to year, which was established in chapter 4. And then this is to just go from year 0 to year 37 without the middleman. And there are reasons that sometimes we want all those middlemen, middle women, whatever. And then there are reasons sometimes we just want to know the ending value because that's all we care about. A couple other things just to point out, that your total interest, now interest is the difference of what you have at the end and what you put in. So that's the ending value of what year? Well, whatever year they ask about, minus your initial deposit, what you put in at the beginning, the original value, AKA, how do I want to put this? P. P is the principal, that's the original deposit. Okay, so, and remember what I called total interest was free money. You're not going to see that on the test, but I think that's a really good phrase for real life. Interest, if you're the one putting money away, is free money. Now, if you borrow money, that means the bank is the one getting the free money. But these formulas work exactly the same, whether you're borrowing or being the lender. And when you put $10,000 into a savings account or a CD somewhere, you are lending the bank money, and the bank takes that money and then it gives it to someone else to borrow, and it charges them interest. And I can guarantee you that the interest they charge them is going to be more than the interest they give you. That way they get a profit. It almost seems like a scam, but it's not. It's just the classic way of banking. And they have all these different ratios of how much money they have to how much they can give away. And we don't need to get any of that. This is not a banking class. This is bare bones math essentials for math in the real world. Okay, rambling aside, let's get to some examples. Example 1. I love Bob and Jane, so I talk about Bob and Jane a lot. Just two simple 3 and 4 letter names. So Bob deposits $500 a savings account earning 1% annually. Track how much money Bob will have 15 years. State how much money he got free at the end, aka total interest. Now I said to track how much money Bob will have for 15 years. Using the word track in my mind, that means I want to see what we call an amortization table. I want to see that full schedule. I want to see year 1, I want to see year 2, I want to see year 5, I want to see year 14, I want to see year 15. If I just said how much money will Bob have 15 years later and how much money did he get for free, that would mean you can just do the one and done formula. Now, if this was just 2 or 3 years, I could do this by hand and say that year 1, he would have, so what I'm about to write down, I'm not actually going to continue to do. So after 1 year, his new amount would be 500 times 1 plus 0.01. Why 0.01? Because 1% is 0.01. And that would be 500 times 1.01. 1.01 times 500 is 505. So he would have $505. Now, what I did not say in here was how much interest he got. You could figure that out because the interest for that year would be the ending of year 1 minus the beginning of year 1. So he made $5. And then year 2, we should expect him to make more than $5. And this is where I'm going to stop the calculations, but it would be 505 times 1 plus 0.01, which is $505 times 1.01. And again, not actually going to do the calculations past this one, but it would be 505 times 1.01, which is 510.05. 510.05, which means the interest from that year 2 is not $10.05. That's the total interest. The interest he earned in year 2 would be $5.05 because that would be the difference of these two values. If you subtract these two values, you would get just the interest from year 2 alone. If you subtract the newest value and the original, that gives you the total interest. So that's another thing to pay attention to. Are they asking for the interest over just a specific year or a total interest? We're usually interested in total interest, but I can't say that that's always going to be the case. So this is going to be tedious to do 15 times. Am I right? Yes, I am. We're not going to do it that way. This is going to be annoying to do for 15 years. But guess what people did before technology existed? They cranked these out by hand. And it probably wasn't just always 15 years. It might have been 30, 40, 50 years. If we're compounding monthly, each year actually takes 12 of these calculations. So if you had 30 years worth of interest to calculate, that's 360 times that you would be doing this. And you don't have a calculator, you just got your abacus. Whew, that sounds rough, doesn't it? So we don't live in that time, thankfully. We appreciate those who did and the empires that they built for us. But we are going to use Excel to get this job much more efficiently. I didn't need to widen that one, but that's okay. We'll just widen them all. And for this much more basic problem than what we'll get into later, we're going based on years. If we compounded monthly, I'd have to break this down into months. So year 2 wouldn't even start until 12 months later down here. But again, we're compounding annually, so there's no complication there. Then we have our starting balance. Then we have our interest. We have our ending balance. Year 1, 2, your 3. You could type all 15 of these if you want, but if you just do 1 or 2 or 3, I'm sorry, 2 or 3 of these, you can highlight them all. Remember, highlight is click anywhere, drag, then let go. Then grab the fill handle and drag it down. Now, if I need 15 years, I got to go to row 16 because the first row is labels. See, labels in row 1, so year 1 starts on row 2, meaning year 15 starts on row 16. And if you under or overshoot it, does it really matter? I mean, oh, here we go, let's just stop here. Oh, nope, I got to go further, so let's just go a little further. Not good enough. Not good enough. Oh, whoops, I overshot it. Undo, and that was intentional. There you go, 15 years. If you want to put the starting balance somewhere over here and then just do a fixed cell reference for that first one, that's fine. But by year 2, you'll end up linking them. If you just want to type the initial balance of $500, you can type the dollar symbol first, or you can go back and click it and hit currency. Lots of ways to get those formats appropriate. But since we are talking about money, we should have 2 decimals displayed. The interest, remember, we're going to be doing this line by line. So this is not exactly what I had on my notes. I didn't have anything about just the direct interest up here. So I will remind us of that. And since I'm going to squeeze it up here, I'll put it in green. So just interest, it's all you're doing is you're getting rid of the one part. It's just the original times the rate. Or, I'm sorry, the old, not necessarily the original, it's only the original for the first year or first month. So it's the old amount or the previous balance times your interest rate. Another way of writing that again is interest equals the previous balance times your rate. And that's only over one period of time. So if we're compounding annually, this has to be over 1 year. If we're compounding monthly, it has to be over 1 month. If we compound monthly, you can't do 12 months worth of interest all at once using this formula. It's much more complicated than that. All right, so back to Excel. So our interest is equal to, well, hold on, we need the interest rate somewhere, which we said was 1%. I'm just going to type it way over here. It doesn't matter where we put it. Interest rate, and more specifically, the annual interest rate. My column. And you can bold things, you can color things. That's not the point here. And I believe we said 1% for the problem. So 500 bucks, 1%. It's not a lot of money, and it's not a very good interest rate, but we're just starting out here. So our interest should be the product of that year's beginning balance, which is the 500. You can click or type cell B2, then times the interest rate. When I do this, spoilers, there's something slightly wrong about this that we will correct, and it's the same thing that I corrected in the lecture earlier. Now this $5 is accurate. The ending balance is just the sum of what we had before and what we got for free. So equals, just add these two things, boom, plus boom. $505, the same thing we came out by hand. Now remember, this is extremely important. I'm actually just going to type this out as a sentence somewhere. You must link year 2's start to year 1's end. How do we do that? We click in year 2's start, we go equals, and then we just click the ending balance from the last year. It's as simple as that. This right here is going to continue to be an issue. All right, the interest. Well, if you drag the formula down with the fill handle, you see that you get nonsense. You might think, oh, we'll just drag this down and it'll fix it. No, it doesn't fix it. It says we earned $0 in interest. Remember, you can double click a cell to see what formula is in it, and it'll show you the blue boxes, the red box, where it's grabbing all the numbers. So double click where we have a issue that doesn't make sense. Double click. Blue box is in the right spot. It moved down because we wanted to keep moving down. Red box is in the wrong spot. It moved down and we don't want it to move down. We need it to stay fixed on the cell where that 1% is typed. So that one is wrong. So let's just hit enter to get out of it. We will delete that cell. So click it and backspace, hit delete, whatever you want to do to clear it. Now we got to go back to the original interest formula. So we're going to double click. The blue and the red are good, but remember, we don't want this red moving, so to make sure it doesn't move left, right, or up or down, we double cash it in front of the letter and the number. not cash G4, it's cash G, cash 4. We don't do anything with the blue one because we did want that to continue moving down. All right, well, the $5 is still good, so that's a okay sign. But here's the real question is, when we drag it, do we get more than $5 of interest? We expect $5 and, what did we say, 10 cents? 5 cents, 5 cents. Yeah. The $5 and 510 is what maybe had the 10 cents in my head, but that was wrong. The interest went up a little. And then this formula added the 5 of 5 and the 505, $505 and $5.05. It added those two. You got 510.05, which is exactly what we calculated. So that's a good sign. In these finance spreadsheets, once you have year 2, you should be good enough in general to just highlight the whole row and drag it down. Now, I did show you how there can be some complications sometimes. Maybe when you do this, if you had a fixed deposit for every single year, it may increment it by 1. So then you just want to do a column at a time in terms of filling it down. When in doubt, try something different. If you do something and it looks wrong, undo it and try doing something different. Insanity is doing the same thing over and over and expecting different results, as they say. So if you get something that doesn't look right, undo it and try something different. But this looks pretty good. So we have tracked a full 15-year period of Bob's finances from just putting $500 away in an account and not touching it, not adding to the pile, just letting the interest accrue. In the real world, this 1% interest rate is going to change at some point. That's how the real world works. So we're not accounting for that, but that will never be an issue in here. We're not going to account for multiple interest rates year to year to year. It can be done in Excel, but by hand, it's a nightmare. Because you'd have to go and say, okay, well, year 1, we got 1%, so type this cell times 1%. Then for year 2, if I say, oh, we got 2%, so you do this cell times 2%. Maybe year 3, we get 0.5%, so you do this cell times 0.5%. It would just be a little more tedious because you'll have to type in those interest rates for every single year because they'd be different. But then it's just tedious. Doing this by hand, that tedious is exponentially increased. And I didn't say this, but let's make a chart. Let's remind ourselves how we make our charts in Excel. So all I want to do is track, and you could be told to track just the interest amounts or just the ending amounts. Let's say I said to track the interest. So you highlight all of the years, including the label, because we don't want to just, if you just highlight the years, it won't say year anywhere, and we need to put that label in there. And we've talked about how tedious that is. And if you've forgotten how to do that, first of all, highlight the label to avoid the next thing. But if you don't highlight the label, you can go back to the first week or two's videos and find ways to add those back in, as well as the videos inside of my math lab. But I'm not going to reteach that. So highlight. Then, if I was down here, if I had scrolled to like a whole bunch of 40 or 50 years, I can't hit control yet. If I hit control, let me show you what happens. If I hit control and then scroll up, this is what happens. It's a zoom. So that doesn't quite work. Whoa. So I got to make sure I'm not hitting control if I was down here. That way, when I hit scroll, I can just go up. Now, if I'm not holding control, and when I highlight end, the years go away. So remember, highlight the years, let go. Make sure you're back up at the top. Start holding control now. Click and hold. Just keep dragging until you're done. Let go of the mouse, let go of control. Maybe you can let go of control and then mouse. I'm not saying. I will let you experiment because there's millions of ways to do things in Excel. I mean, at least thousands of ways. All right, so we got all the things highlighted. I'm doing just a graph of the ending balance, so let's insert. This isn't a homework, so I don't have to do any specific recommended charts. We're just trying to get a basic idea. So the basic scatter chart. And we can see it says end because that's at end. If you wanted to make this more specific, you could say ending balance. And this really looks like a line. It really looks like a line. And we can see the years down here, and they're not labeled for some reason. That was weird. I don't know why it didn't label that, but that's okay. I'm not going to focus on that for now. Again, you can go and insert that in ways. If you wanted to, okay, well, we said this is exponential growth, but it looks like a line. what would that line look like? Wow, it actually looks really good. I don't think this is a bad estimation at all. The reason this is a pretty good estimation is because, first of all, we're not looking at a very large time span. And second of all, the interest rate is very low. To see that exponential explosion where this thing starts really bending, you need either a high interest rate or a longer period of time, or both. If you have an interest rate of like 20%, you can see the explosion in 5, 6, 10 years. If you have an interest rate of 2%, 1%, that's going to take maybe 60, 70 years to explode, which is why you don't retire into accounts that are 1% or 2%, because you're going to work for 60 or 70 years and nobody wants to do that. Now, again, no matter how low that rate is, if I look across thousands of years, this thing will eventually start bending. Let me demonstrate that. So let me just kind of put that one to the side. Now let's take this thing and let's just fill it down. Make sure everything's okay. Yes. Let's fill this down for like, I don't know, 100 years total. So down to row 101. So we're going to pretend that we put this money away for 100 years. Oh, wow, we turned into 1,300 bucks. That's great, right? Let me do this. So let's highlight all 100 years. Let go of the mouse, scroll back up. I'm going to hit and hold control. Grab the labels, drag all the way down. Let go of everything. Insert, scatter chart. And you can see here that it doesn't look as linear. It doesn't look like a perfect line. If I were to add chart element, trend line, it doesn't look that terrible, but it's not perfect. That's because these are not lines. These are exponential curves. They bend. So this is an okay approximation, again, because of the low interest rate. Check this out, though. Let me just put this up closer to the top. Zoom back in. If I make that interest rate 2%, all the numbers in here are going to change. The graph is going to change. Look at that. Now it's bending a little more. A higher interest rate gives us more of that bend. It's almost starting to explode. I feel like we're hitting the explosion point at 100 years now. The line is less accurate as a predictor. Again, lines are only good for complicated data and small values. Either it's a small rate or a small time. 100 years, 2%, we're getting out of that small range. What if this is 3%? Even bendier, and the line looks even worse. Especially in year 100, it says the line approximates us having about 7 grand, but in reality, we have almost 10 grand. That's kind of far off. 5%, even more bending, the line looks awful. 7%, even more bending. We're really seeing that explosion around, I don't know, I'd say year 70 to 80, somewhere in this ballpark. Again, there is no singularity of the explosion point. I'm just saying when it starts bending more and more, when it really starts taking off in a vertical manner, vertical meaning more money, more problems. 10%, wow, the line is just trash now. This is a massive explosion. 20%. Now it still is taking a very long time to explode in this graph, it looks like, but at the same time, that's because now, look at this, that is $10 billion. So after 100 years of a 20% interest rate, I gotta make this thing really wide to see all those numbers. Even wider. That is $41,408,987,261 and a penny. Can't forget that penny. So if you somehow manage to put $500 away in a 20% account for 100 years, which does not exist, yeah, most of us aren't going to live long enough to have done that. I'm not saying all of us, at most. But man, does that money just explode? Good investors, really, really, really good investors might be able to do this. I'm not saying anything that anybody can absolutely. This is a tough goal to achieve over 100 years. I'd say really good investors are probably going to hit 10%. And you could say, all right, well, you know, Bob's great-great-grandfather put $500 away, and he had this trust fund set up that just every year it's averaging 10%, some years less, some years worse, but the average is 10. And then over time, ultimately, You got $7 million after 100 years to give to your great-great-grandbabies. Now, of course, $500 100 years ago is probably like $50,000 after 100 years due to inflation, or maybe 20,000, 50, somewhere in that ballpark. But even still, that 500 turned into 7 million. You definitely made money. You definitely see the explosion in the graph. But again, for that trend line, where am I? Design. There we go. If you want to do the exponential instead, you can hardly even see the points between them. It's a perfect fit. The line is trash for this with big interest rates or very, very long amounts of time. So there's kind of a porridge situation here. Too hot, too cold, just right. Okay. So all the answers were in the spreadsheet originally. We saw them. Let me change everything back so just we can't officially answer it. So we're just going to hit the undo button a whole lot. There we go. Interest rate 1%, all 15 years. That was just a movement. Okay, perfect. So how much money did we have after 15 years? $580.48. Ending balance, new balance, same thing. 500, I already forgot the number. 580.48. 580.48. Meaning the total interest, the difference of the ending balance minus the starting balance, the 580.48 minus the 500 we deposited, which would be $80.48. Want to see another cool way to calculate that free money if you're doing this in Excel? And I showed this in the other class as well. If you just add up the interest from every year, that'll give you your total interest. So in Excel, I can just go equals sum, open a parentheses, drag all those, close it, enter, $80.48. I could have used Excel to do the calculation the other way as well. I could have gone equals the final ending amount of 580.48 minus the starting value of 500. Same answer either way. Two ways to get the job done. Do I care which way you do it? Nope, I don't. Now, if we are doing a true retirement account where we continue to add money into it, you can't just do ending balance minus starting balance. You would have to add up all of the deposits you do. That would be your total deposits, and you subtract that from the ending balance. All right, so let's do another one of these. Actually, before we do another one, I said we do the formula as well. So we know the ending amount, we know the interest amount. Let's see if we can calculate that by hand using this formula. All right, so let's just see if I only asked, if I didn't say track, if I just said how much money will Bob have 15 years later? So we could go at year 15, our future value A, aka the ending value for year 15, and there are a lot of different letters that they use for this, as we'll see in our notes over the next class or two. This is the product of the principal, which is the initial deposit, that's the 500, so I'll label things. P equals $500. R is 0.01 and T is 15. The interest rate is 0.01 because 1%, the T is 15 because 15 years. So we go 500 times 1 plus 0.01 raised to the 15. If you want to simplify this, you can. That's 500 times 1.01 raised to the 15. Do not multiply these numbers together. Do not multiply those numbers together. Do not multiply those numbers together. Exponents come first. Now, I could type this in my Excel spreadsheet. I can absolutely use Excel to do that, or I can use a traditional calculator. So traditional calculator, here we go, 500. I'll show it both ways, parentheses, 1 plus 0.01. Your calculator may not work exactly the same as mine, so you have to learn it. Raised to the 15th power. Some of you may have to hit the times before the parentheses, FYI. And we get 580.48. See, Excel was only showing us to the nearest penny, but there were some tenths and hundreds and thousands of pennies in there. We just weren't seeing them because of the display. I could have changed the decimal precision to see that, but I didn't want it because money. Or if I type it the other way, 500 times 1.01 raised to the 15, same exact answer, 580.48. And then of course the interest is still 580.48 minus 500, which is 48. I'm sorry, 48. 80.48. I was saying the cents before the dollars in some weird universe. So the formula works. Could you let Excel do it for you? Sure, I can just go to some random cell and type equals 500 times parentheses 1 plus. I can even do 1% instead of 0.01 in Excel. Close it, raise it. This little upside down caret, which for most keyboards is Shift and 6, that's your exponent. And then we raise it to the 15th. And look at what we get, $580.48. If you double click it, you can still see the formula. You enter, you see the number. Even if you single click it, you can see what you typed up here. Now remember, you have to type the equals. If I just type this, if I don't type the equals, it just displays what I typed. With formulas, with Excel, the first thing you have to do is equals if you want it to think for you. The equal says, do the work for me, and it did the work for you. Excel is a perfectly fine calculator, but you have to be careful with order of operations and knowing how to type things in Excel, which is why we talked about that at the beginning of the semester. All right, now let's finally get to another problem. Example 2. It's weird. Jane deposits $5,000 to a savings account, into an online savings account that earns 2.5% interest annually. Now, I might say compounds annually. That's another way of saying it. I'll put that in parentheses. Those are just two different phrases for the same meaning. Earning interest annually means it compounds annually. Track how much money Jane has for 32 years. Let's be a little more, or a little less rounded. 32 years. So Jane just puts 5,000 to an account and she's going to go, now, I know this isn't just my retirement, but it's $5,000 I'm just sitting on. I don't really need it unless an emergency comes up. So let me just put it to the side, but I don't want to risk it in the market. I don't like risk, so I'm not going to do traditional retirement. And having that mindset is not a great idea, FYI, but a lot of us still keep that mindset, and I can't tell you what to do. I can just make suggestions. So Jane still got her traditional retirement set up, but then she's just got this safety net, this $5,000 in a safety net in addition. That's okay. That's perfectly fine. I believe, as most financial independence experts believe, you should have 6 months of your expenses put away in a safe account somewhere. That way, let's say you lose your job, you've got a couple of months to at least live off of and hopefully find another job as soon as possible. Or let's say some big giant medical expense comes up, or you have to rebuild your bathroom from scratch and have to buy thousands of dollars of materials and stuff like that. Then you have a safety net without having to go get a credit card and put it on that and pay 24% interest APR, because you're already seeing what ridiculously large interest amounts can do over time. And we will get to credit card math later. I promise that. I love credit cards, but they're bad for us at the same time. We have to know how to use them correctly. And if you can't handle that, don't get them. All right, I'm getting sidetracked. I really love this finance stuff, so I do that sometimes. All right, so since we want to track for 32 years, we definitely don't want to do this by hand. That sounds awful. This is where we go, hey, Excel, do my job for me for the most part. So let me just make another spreadsheet, zoom in a little, and the same year, starting amount, interest, ending amount. Technically, you don't need an interest column. I could just go starting and ending amount, and then the ending amount would be the more complicated formula, new equals old times growth factor, new equals old times 1 plus R. I can completely skip the interest column if nobody asks about the interest each year. You can just make the ending formula, instead of adding the starting balance and the interest, you can just do new equals old times 1 plus R. All right, so year 1, year 2, year 3, year 4, it doesn't matter how many you start off with, just highlight more than one, drag them down. I think we said 32 years. Holy moly, that went down quick. Let's get back up. So go to row 33, looks pretty good. Starting balance, we started with 5,000. And I can put that initial deposit. That was 5,000. That column. And then just somewhere else, I'll type interest rate. And then that'll be the 2.5%. Or you could write 0.025 if you don't want it as a percentage. So for my starting value, instead of just typing the 5,000, this time I'm just doing it different. I don't have to do it this way. I use a cell reference though, that way I could quickly change it, and it's just a cookie cutter Excel spreadsheet that I can do the next problem on, and the next problem on, and the next problem on. I don't have to redesign it every time anymore. So instead of typing the 5,000, I go equals, and then whatever's here. Boom. Interest. That's the product of the balance, that year's balance, and the annual interest rate, which is 2.5%. Now we already know we're going to have to fix that, so let me go ahead and adjust it. By fix, I mean the cash symbols. Double click. We know we don't want the red box moving, so cash in front of both letters. The ending balance would just be equals the sum of these two things if you want to do it that way, but it's only two things, so we can just go equals this one plus this one. Boom. $125 for free the first year, giving us $51.25 now. Link the starting of year 2 to the ending of year 1. Boom. Probably going to need to widen these columns some. It's pretty common unless you just zoom in ridiculously. We already fixed the interest formula since we've practiced well at this point, so let's drag it down. The ending balance formula should be the same, so let's drag it down. Now that I have year 2 completed, we can highlight them all and drag it all the way down to year 32 if we like. Or we could do it column by column, it wouldn't matter. And look at this, in 32 years, we've gone from 5 grand to 11 grand. We've just more than doubled our money. That's not awful for just a safety net fund for a pile of money that we're not trying to retire off of. It's nice to just have this safety net somewhere and us getting a little more cash to at least keep up with inflation. And that's the thing. This interest rate really isn't much higher than inflation, an average of 2% so far in our history. That could change. Things like pandemics can change inflation rates, especially with some of the things that the Federal Reserve is doing to balance that. Who knows what the long-term results will be? There's lots of wild speculation, but sidetracking aside, this $5,000 right here in year 1, if inflation is 2%, there's actually a cool trick. You can just subtract the two numbers. If inflation is 2% and your interest is 2.5, that means your true interest, the money you're really getting for free after accounting for inflation, is really just 0.5%. So in terms of dollars now, your $5,000 today, in today's denominations, is going to grow to $5,865 after 32 years. So again, this pile of money will actually be $11,000 and some change, but the true value of it with inflation considered is really only $5,800 when you think about in today's dollars, which is how we all think. Nobody thinks about in terms of a future dollar. It's too hard. I don't want to say it's too hard to grasp, but it's just more complicated to grasp. Even me, when I think about, what my retirement money might be 20, 30 years from now, I'm thinking about in terms of today's dollars. So when I lay these numbers out in my spreadsheets, I will have a column where, all right, here's the true interest rate, and then I'll make another one where it's adjusted for inflation. And you don't see the number as big because we're accounting for that. Again, it's still a little bit of growth here. But yeah, okay, so the actual numbers we had, how much do we have after 32 years? Well, year 4 is here, year 11 here, year 22 here, year 32 here. I'm not going to write down anything specific because I said to track the whole thing. I will, as well as doing this, though, find the total interest. That's usually something I'm interested in, pun intended, total interest. That would just be, you can do it two ways, as I've already said. You can just sum the interest column, or you can take the ending balance and subtract the starting balance. If you're making multiple deposits, though, you have to add all the interests up, which is not the case here. So let's do the sum. Equals sum, open parentheses, and let's just drag and drop all the interest amounts for all 32 years. Close parentheses, hit enter, and that's how much money we got for free. Now you might be thinking, well, Mr. Beckner, when you accounted for inflation, we didn't really have that much more money. Well, that's because it was a 2.5% savings rate. That's why you find mutual funds that get you 7, 8, 9, 10%, because then when you subtract the 2% inflation, it's really not a big deal. You're still making buku bucks. Now, maybe you don't trust that this is accurate. Let's see if that other formula gives us the same answer if we can go straight to year 32. So for year 32, the future value, what I like to call A, but we'll have different letters as we'll see next class, is equal to the original deposit, P, 5,000. Again, it's A equals P parentheses 1 plus R raised to the T. Or minus if it was decay, but obviously this is growth. So parentheses 1 plus 2.5% is not 2.5, it's 0.025. And then we're doing this for 32 years, so our exponent's 32. Again, you don't have to simplify any of this. You can just let the calculator do all that for you. And that's what I'm a fan of. The less I have to do, the less likely I am to make a mistake. 5,000. Again, you might have to hit times in your calculator, so I'll show it that way. Open a parentheses. 1 plus 0.025. Close the parentheses. This upside down V is our exponent. We call it a caret. And then 32 years. Drum roll. Is that the same answer? Looks the same to me. $11,018.78. And then if you were to subtract the initial deposit of 5,000, you can see that our interest is still $6,018.78. Exact same two answers. All right, let's try another one. Bob. Bob deposits no, let's not do 50,000. That's too much. Let's do 20,000 to a mutual fund that earns 7% APR. Compounding annual. Track how much Bob's going to have after, or for a total of, let's see, 25, let's do 40 years. 40 years is a pretty common amount to work if you're coming out of college, especially if you get a master's or a PhD. Maybe it takes you a year to get into your real job. So, you know, like 25 to 65. Yes, if you get your good job at 22 and you retire at 67, which is Social Security age right now for full benefits, which please do your best to try and not retire on just Social Security. Who knows what'll happen to it after 30, 40, 50 years from now. Plus, it's really not that much money in the grand scheme of things, unless you made a boatload of money. All right, so 22 versus 67, that means 45 years for someone who really does work directly out of college until that Social Security full amount year, so to say. But let's just say Bob got into this a little slower. Maybe Bob from 22 to 27, maybe Bob spent 5 years just living with his parents, saving up money for whatever, maybe a deposit on a home, maybe a brand new car so he didn't have to get a loan, or so whatever. Maybe this 20 grand is in addition to all the other savings. Because if Bob's making 50, 60 grand a year living with his parents, if he's not spending every single penny, if he's actually saving properly because he's not paying rent, he's probably not spending too much on groceries if mommy and daddy are helping a little at least. Who knows what kind of utilities he's helping out with. I don't know. Hopefully he's giving them some money because, shelter and such. But that's going to be much better than just living on Bob's own. So maybe Bob in this 5 years has saved up 40 grand for a deposit on a house, and he bought his house. And then he had this 20 grand left over, and he goes, all right, well, I'm good right now, so let me put this into a mutual fund and let's make this thing work for me. Let's make the money start earning money. 7%, again, historic kind of average. Some people will say historic average, some will say with inflation accounted for. You're going to see a lot of variable answers between 7 and 10% if you start looking into this stuff. And I do encourage you to do some research on your own. YouTube, I cannot tell you how much I've learned just off of YouTube and Google. It's insane what you can find out, and from simple to complex. And do not let this go. Learn this stuff. It will change your life. I can guarantee it. All right. Again, not necessarily traditional here, but Bob puts 20 grand in his mutual fund, 7% compounding annually. Track how much he has over a 40-year period, as well as show how much interest he gets. So let's go to Excel. Now here's why I did this last problem this way, where I put the deposit over here and the interest rate over here, so they're just referenced. I don't have to set up a new years column, starting and interest, ending formulas, such and such. All I gotta do is just change these two numbers. That's it. Now I'm going for 40 years, so I do need to at least extend this. Let me just take this and move it. Maybe down one more. That should be good. So let me grab row 33, which has year 32. Let me drag this down so that we'll see 40 years worth of material. Now this is the old problem. I haven't changed anything yet. But now Bob has put in 20,000, and he had an interest rate of 7%. And in the snap of a finger, sorry if that was loud, the whole thing's done. Are we seeing the beauty of Excel here? I didn't have to relink the old and the new because it was already done. I didn't have to type the start here because it was over here. And that's the only time I need the starting value. This one, oops, that was weird. This one links to that one, so that's good. The interest formulas are all still the same thing. The ending formulas are all still the same thing. I had to throw in some more rows, but boom, there we are. Now this total interest formula, I don't think is going to have everything, so that might throw you off. I go, how does he only have $154,000 in interest if he's got $300,000 after 40 years and he only put 20 grand in? He should have about 280, right? Well, look at this. It's only going from C2 to C33. It's stopping here. See, look, it did not account for the other years. So I need to just, when I double clicked it, I can just drag and drop to the extra years, or I could have retyped it. Either way, now we see an answer that makes more sense of about $280,000. We have our ending amount. So now Bob turned his 20 grand into 300 grand by just putting it aside and not touching it. Is he paying taxes on it? I don't know, maybe, maybe not. Maybe he's paying taxes on some. He's definitely going to be paying taxes on some. It is impossible to deposit 20 grand in 1 year and not pay taxes on at least some of that interest. You could have put 6 grand into a Roth IRA that year, and then the interest on that 6 grand would be tax-free, but then the other 14, the interest from that 14 grand would be taxed. So you could actually turn this into two problems. You could have one section where you've got $6,000 of it, and then that final interest would be the tax-free amount, and then you have this thing just repeated somewhere else with 14 grand, and that would be the amount you're paying taxes on. Alternatively, if you wanted to be slick, you could put $6,000 in year 1, then $6,000 in year 2, $6,000 in year 3, and then the remaining 2 in year 4, and that would ensure that all of the interest is tax-free if you put it in Roth IRAs. Now, you will lose a little bit of the interest overall since you didn't put it in all at once. However, maybe you would actually get more money in the end because of not paying 25% taxes or 22% taxes or whatever it might be in the year 2060. because we have no idea what taxes will be in 2060. We don't even know what taxes are going to be 2 years from now or 1 year from now, especially in a year when we change presidents. So this is some powerful stuff. In fact, let me just show you everything I was talking about. So let me just literally copy all of this. I just Control C for copy. I'm going to put it down here, and then I'm going to put it here. Now the starting balance, let me just type the $6,000 here. And then is the interest in the right spot? Yes, that red box is good. Then for this one, so the left column is my tax-free. My right column, this will be the 14,000. That's the one you'd have to pay taxes on if you put everything all in at 1 year. We're just having fun here. So that says the $6,000 that you put in, this is your tax-free. It would be equal to this amount minus what we put in, which was the 6. So we get $84,000 in interest that's tax-free. That's pretty sweet. But you can see, because we put 14 in over here, 14 is much bigger than 6, we're going to get much more interest off of that. So this taxable interest would be this value minus the 14,000. So we got about 84,000 we're not going to pay taxes on, and we got about 195,000 that we are going to pay taxes on. That's pretty cool. Now you might say, well, Mr. Beckner, what about 401ks? You can put in 19,500 into a 401k every year. Yes, you can, but that has to be withdrawn from your paycheck directly, and you're probably not getting paid $19,500 all in one paycheck. And if you are, remember your teachers who help you out. Hint, hint, hint. I'm kidding. So 401ks are cool. They're awesome, but that's direct pay from your employer, or sorry, money that comes out from direct pay from an employer. This $20,000 you just had sitting around, you can't just magically put it into a 401k. You could say, all right, over my next 10 or 12 paychecks, take all of my paycheck until you hit that 19,500. And then you could just live off of the 20,000 that you've got sitting in that savings account. And that would be one way to get it all in. So sure, there is a scenario in which you could get almost every penny of interest. There'd still be $500 that would be taxable, but then you go, well, hey, just put it in the IRA. Boom, there you go. It's all tax-free. And yeah, it is. It's a sneaky situation, but you can make it work. All right, so